So what I want to talk about today with you guys is volume of a solid where we're revolving a rectangle around an axis, which will create a volume. And I'll show you that an animation of that in just a minute, okay? And when we rotate a rectangle around an axis, okay, what can happen is it forms what's called a disk, okay? And so what I want you to know and understand is what's the volume of a disk, okay? So right here, this is a radius, okay? And I'm gonna call that for right now, big R, okay? And this is my center of my circle. So the area of this area would equal pi r squared, okay? That, or big R squared, okay? So right here, that shows itself in the three-dimensional object. I've turned this and I've flipped it so you can, and rotated it so you can kind of see the edge of it, okay? So basically what we're gonna have here is we're gonna have a rectangle, and here's my rectangle, all right? And we're gonna rotate that rectangle, you're gonna see around the center, okay? Around, and that's gonna be my axis. And this is my big radius R, okay? And this right here has thickness to it, okay? So this right here is my dx. And that's gonna be really, really, really small, right? So like paper thin slices of these rectangles. So that would make this width right here really, really small, okay? So the volume of this would be the area times how high you're stacking it, or when I say high, I mean what's the width of it that you're stacking it, okay? And that would be this dx. So the volume would be pi big R squared, because that's the area, and that would give you square units, times dx, which if they're the same measurement units, okay, we would have cubic units then, okay? And what we're gonna do is we're gonna integrate this, okay? And that will give us volume, all right? Okay, so let me show you an animation of this. Okay, so I'm gonna rotate this. Excuse me. Okay, so I'm going to rotate this around this axis of rotation, this one right here, okay? And I'm going to do this manually. And what you're going to see is it creates this disk. Okay, now this is just going to be one disk, okay? Let me come around again to fill this part in right here. It's kind of jumping around a little bit. Okay, and I'm going to revolve it so you can see it. Okay, so what we're gonna do is we're gonna do a bunch of these. We're gonna accumulate a bunch of these discs, and each one's gonna have this width right here that I'm pointing at, okay, or the thickness right here, is gonna be infinitesimally small, okay? All right, so that's what it's gonna look like. So we can rotate, this one's being rotated around a vertical axis, but you could also rotate around a horizontal axis. And I'll show you some of that in just a minute, okay? So you know what? Actually, let me go to the next one. I'll just show you. Okay. So right here, okay, this is one big one. Okay. And we're going to rotate it. If I revolve just one of these, you see how I get this shape right here? And let me reset this. And I want my axis of rotation to be the x-axis right here. Okay. Because this is what we're not going to talk about. That's actually tomorrow's lesson, okay? So there we go. So it's going to make, that's one disc, and then we're going to make it really thin. Okay. And then here's a bunch of them, right? And you're going to make them smaller and smaller and smaller and smaller, okay? All right. Okay, hopefully that starts to make sense, okay? Okay, so what I want to talk about right now is vertical discs. Okay, so I'm going to create some function. Let's say it looks like this, right? Just kind of a wavy function, you know, some like trig function maybe or something. Okay, and let's call this f of x. Okay, all right, and we're going to rotate this. We're going to revolve it about the x axis. So we're going to rotate, and I'm going to use red for this. We're going to rotate around the x axis. So you can revolve or rotate about the x-axis. Okay, so what you want to do is you want to draw your radius, okay, this radius that we're talking about, and that radius of one of the discs, we're going to start from the line we're rotating around and draw towards the function, okay? And so this is going to be our radius because we're going to rotate this around this axis. So that's my big R, okay? That's my radius. And what it would be in this case would be f of x minus 0, which would just be f of x. So your radius is going to be your function, okay? It's going to be f of x, all right? And that's what's going to be important is your radius is going to be changing, okay? All right? Okay, so let me go to the next one. This one's also going to be vertical, okay? Let's say it's this. Okay, so that's our function f of x. And this is still going to be a vertical disk, okay? And let's say we're going to rotate it about the line, straight line, y equals k. Okay, so I'm going to draw my little rotating around symbol, okay, around this line, right? So we're going to go from that to the function. So we'd go up, right? Okay, and that is going to be my radius. Okay, so in this case, it wouldn't be f of x minus 0 because that's got shifted up. It's going to be f of x minus k, and that would be your radius, okay? And what we're doing here is we're revolving about y, the line y equals k, okay? Now, if the line we were rotating was above, okay, then what would it be? We're still doing, this is going to be important, it's top minus bottom. So it would be k minus f of x if this line we're rotating were above it, okay, or f of x was below the line, okay. Then let me grab a different color and I'll show you. Let's say we have this. This is our g of x function, right? Okay, and we still want to rotate around the line y equals k. Then what it's going to look like is this, okay? From the line we're rotating around, the axis that we're rotating around, to the curve, right? We're always going to draw that. And that would be my radius that's going to be created when I start rotating this around, okay? Now, in this case, it's still top minus bottom. So it's going to be k minus, and we said this was g of x, right? So this one's going to be k minus g of x, because that will always give you a positive value. If you do top minus bottom, it's going to give you a positive radius. That's why it's important to do top minus bottom, okay? And when we draw these, when the axis we're rotating around is horizontal, okay, then our line that we're rotating, our radius, is going to be perpendicular, so it's going to be vertical, okay, and you're going to make vertical discs. And this thickness would be dx, and this would be dx, and this would be dx. It's a little change in x, right? Because we're going to do horizontal discs next, and it's not going to be dx, okay? So these two, the next two that I'm going to do down here, let me slide this up just a little bit. These are going to be horizontal discs. Okay, so now our function is going to, you would do this when when you don't have functions. Okay, so something like this. Okay, and this isn't f of x, instead it's f of y. Okay, and we're going to rotate around the y-axis. So this time we're rotating around the y-axis. Okay, so revolve about y-axis. Okay, so we're rotating around a vertical line, so that means our radius is going to have to be perpendicular to that. So I'm going to draw it from the line I'm rotating to the curve, right? And now this time, this is my r. Okay, And so my R would wind up being, and instead of doing top minus bottom, we're going to do right minus left. So it's going to be f of y minus 0. Or my big R is going to be f of y. Okay? Now, what if I want to rotate about this line, this vertical line? Okay, and let's say it's y, not y, whoops, x equals k. Because the vertical lines have to be x equals a number. So k is going to be some number, right? All right, and then our function, let's say it's somewhere over here. Okay, and this is going to be f of y. Okay, and we're going to rotate it around the line x equals k. So from that line we're rotating around, I have to draw a perpendicular for the radius and draw it to my function. So it's going to be horizontal, right? Okay. And so this is my radius. From here to here is my radius, okay? Now, how do you get that as a positive length? Well, you have to do right minus left, right? Okay, so r, the radius, is going to be k minus f of y. And that would be my big radius. And what we did here is we revolve about the line x equals k. Okay, and so because you're going to need your radius, and you're going to know, okay, like for this, we're going to need to know, okay, where do we start making these discs, okay, and where do we stop it? So the low point where we start it and the high point where we stop it, okay, where we start it to where we stop it, we're going to integrate that, okay, and we're going to collect, we're going to add up all of these discs, and to add up the discs, we're going to do pi r squared, okay, because that's the area, and then times these little thicknesses dx, okay? And so you're going to see what we're going to do next, okay? All right, so turn the page and we'll do the first example. Okay, so for example 1, we want to set up and evaluate the integral that gives the volume of the solid formed by the region bounded by the x-axis, the y-axis right here, and the graph for y equals 4 minus x squared by revolving the region about the x-axis. So this is the line we're rotating around, right? Okay, and so we have to first come up with our radius, right? And we always draw the radius perpendicular to the line we're rotating around to the curve. So like, I'm gonna just draw it here at 1, okay? So we're gonna go all the way up here, okay? And I'm gonna label this R, okay? Now, before we, well, let's go ahead and do this. What would R be? Okay, so R would be top minus bottom, right? And so the top is this curve right here, which is 4 minus x squared. And I'm gonna just put it in parentheses, 4 minus x squared. That's the top. What's the bottom? Well, it's gonna be 0, so minus 0. So my big R is gonna be 4 minus x squared, okay? And then the volume is going to be pi r squared, pi big R squared. All right, let's do area first, because that kind of ties into like the next 3 days, okay? The area of one of these discs, so the area of one of these discs is going to be pi big R squared, okay? So I have an animation. Before we go any further, I want to show you an animation, okay, of this. Okay, so what we have is a picture of what you see on your page, okay? And so you're seeing the area right now between the curve, the y-axis, and the x-axis. Okay, so I'm going to break this into, this is like infinitesimally, the width is really, really small, okay? It's infinitesimally small. So I'm going to make these I'm going to do left rectangles, okay? And I'm going to make 5 of them, okay? And I'm going to do the LRAM, okay? So there we go. That's 5 of them, okay? All right, so I want to show you, okay, we're going to take this and then we're going to create the volume by rotating each of these, okay? So this is like a big thick radius, okay? We're going to rotate them around the x-axis, which is y equals 0, okay? And we'll do that, and then we have this, okay? Now, what's kind of cool about this program, okay, is it's 3-dimensional. So I can twirl this and you can start to see these discs, okay? And I can come this way with it. I just think this is the coolest thing, okay? And I'm gonna take it back to rotation. Okay, and what if I created more rectangles? What if I created, let's say 10? Then it would look like this, right? What if I created, this would be the shape of it now, right? And so it's starting to more look like a solid shape, okay? And what if I do, instead of 10, I do 100? Okay, so that's gonna be a lot of them, right? And that's what it looks like, okay? All right, and then you can, I'm gonna also go back and I'm gonna show you I wanted to go back to 5 and I want to show you an animation that you can do with this. Okay, so then I'm gonna do this. It's called animate the object, and you can start to see it rotate around. And here we go. So you start to see these rectangles rotate around, and now when I twist it, you can really start to see these discs being formed. Especially if I take it and go up this way, right? You can kind of see the hollow discs out. And then it's going to go back and repeat. So we're kind of seeing the back side of it, because it's rotating, okay? All right, so we're trying to create this, okay? Now, I'm gonna stop this. I'm gonna get back into XY orientation. And I'm gonna get, okay, a nice smooth, okay? So now I'm doing like 1,000,000 of these discs, okay? And I'm gonna animate this. And there we go. And that's what this thing looks like that we're trying to find, okay? Sorry, it takes a while to do all this. And we're going to go all the way to 2 pi. Okay, and so you're going to see the complete solid of it now. And that's what it looks like. Kind of like a Hershey's Kiss, kind of. Okay, so that's what we're trying to find. And then we're trying to find the volume of this, okay? All right? Okay, so let's go back and we're actually going to find the volume of this. I think I can actually calculate the volume. Let me see. It's been a while since I've done this. Calculation? Can we actually get the volume? No. I don't think it'll tell you the volume here. Yeah, there's something else. I would need to look it up. Sorry guys. I thought I could do it real quick. Okay, so We are actually going to find the volume of this, okay? That's what we're going to do next using calculus. Okay, so what we're going to do, we know from this that the area of the circle that we're creating is going to be pi times our radius, right? And our radius is 4 minus x squared squared. And we're going to start creating these circles at 0, and we're going to end it at 2, okay? So the general formula for this one is going to be the volume is equal to the integral of, well, we're going to start creating these at 0. So the thicknesses are going to start at 0, and we're going to start making these, a whole bunch of them, right? Really, really, really thin ones until 2, okay? And then pi times big R squared, that's the area formula, right? And then if you multiply that by dx, that's going to give you the cubic units we're looking for volume, okay? So this would be equivalent to the integral, the integral from 0 to 2 pi times 4 minus x squared squared dx. Okay, so I'm going to do this one by hand, and then show you that with technology that we can also do this with a calculator, okay? This pi is a constant, and because it's a constant, the properties of integrals, I can bring it out in front. So this is equivalent to multiplying by pi times the integral from 0 to 2, and then I'm going to square this out. So if I square this, it would give me 16 minus 8x squared, and then plus x to the 4th, and then dx. Okay, so now this would be pi times, and it'd be 16x minus 8x cubed over 3 plus x to the 5th over 5. And we're going to evaluate this from 0 to 2. Okay, so that'd be equal to pi times 16 times 2 minus 8 times 2 cubed over 3 plus 2 to the 5th over 5, and then close the parenthesis. That's putting 2 into this, right? And now I need to put 0 in. So pi times 16 times 0 minus 8 times 0 cubed over 3 plus 0 to the 5th over 5. Okay, now all of this is going to be 0, right? Okay, so we don't need to write this anymore. You need to write it once so you show that that part is 0, okay? Because otherwise, I don't know if you know it's 0, okay, or if you just forgot to do that, okay? All right, so this turns out to be pi times, and this would be 32 minus 64 thirds, because 2 cubed is 8, and then times this 8 would be 64. That's where I'm getting the 64 thirds. And then plus 2 to the 5th is 32 over 5, okay? And then these all need a common denominator of, and it would have to be 15. So pi times, and then 32 times 15, I'm putting in my calculator. So 480, so 480 over 15 minus, and then with this one, we'd have to multiply by 5 to get the 15, or 5 over 5, I should say. And that'd be 320 over 15. And then this one, we'd have to multiply by 3 over 3. So that'd be 96 over 15, okay? And then that would turn out to be pi times, and then 480 minus 320 plus 96. And you get 256 over 15. Or this would be written as 256 pi over 15. Okay, and I should have slid that up, sorry. Okay, so I'm going to put this in the calculator and to show you, okay? So if we integrate, for function integrate, right? And we go from 0 to 2, and let me slide it up. Get it out of the glare, there you go. Okay, so 0 to 2 of pi times 4 minus x squared, close the parentheses, squared, and then dx, we get this value, right? And if we type in 256 pi over 15, and we get the same value, right? Okay, so yeah, that is our answer, right? Okay. All right, guys. So it won't, like, these calculators won't do the exact value, and you could do this on Desmos too, and even if you just set it up, because right now I know you guys don't have graphing calculators, or you put it into Desmos, either way is fine. Okay. All right. If you just set it up, I'm good with that. Okay, for these. All right. Let's go to the next one. Okay, for this next problem, we want to set up and evaluate the integral that gives the volume of the solid formed by the region bounded by the line y equals 2, that would be this one, and y equals 4 minus x squared over 4, that would be this one, okay, by revolving this shaded region about the line y equals 2. So we're going to, this is our axis of rotation right here, okay? And so it is y equals 2. I need to put a little arrow on that, okay? Now, what have I said? You will always want to draw the radius perpendicular to the axis you're rotating to the curve, right? So that would be this line right here, okay? And this is my R, okay? Now, what is R? My R is going to wind up being this top curve, which is 4 minus x squared over 4, and then minus this, right? And that's going to be minus 2, okay? So that means my R would wind up being 4 minus x squared over 4 minus 2, so that'd be 2 minus x squared over 4. So my area of one of these discs is always going to be pi times my radius squared, right? And so in this case, my area is going to be pi times 2 minus x squared over 4 squared, okay? Now, the next thing I need to do is I need to know, and I'm going to start them right here, but I do not know what that point is. And I'm also going to end it right here, but I do not know what that point is, right? So what I have to do is solve this system, okay? So I'm going to grab a blue pen, and we need to solve, okay? And it would be 4 minus x squared over 4. When is that equal to 2? Okay, so I'm going to move this negative x squared over 4 over to this side, and I move the 2 over here. So 4 minus 2 would give you 2 is equal to x squared over 4. Okay, and then multiplying both sides by 4, I would get 8 is equal to x squared, square root both sides. And so x, this comes out to be the absolute value of x is equal to the square root of 8, which would be, in this case, it'd be fine, square root of 8, or 2 square roots of 2. So x is equal to plus or minus 2 square roots of 2, okay? So I know that the location of this point is negative 2 square roots of 2, comma 2, because the y is 2. And this one is 2 square roots of 2, comma 2. It would be just as fine, because it's not a final answer, is if you wrote this as a square root of 8 and this one is negative square root of 8. It's an intermediate step, so you don't have to simplify intermediate steps if you don't want to, okay? All right, so how do we find the volume then? Okay, so then the volume would be the integral. We're going to start making them at this x value, so negative 2 square roots of 2, to this x value, 2 square roots of 2, okay? And again, this could be negative square root of 8, and this could be square root of 8, and it would be fine, okay? And it's going to be pi times my radius squared, right? So that'd be 2 minus x squared over 4 squared. And the thicknesses of each of these is dx, okay? So we're just going to put this in our calculator, and actually I'm going to put in negative square root of 8 and square root of 8 because it's just easier to type in, okay? So this volume would be approximately, okay, and I'm going to just put it in my calculator, okay? And so alpha window integrate, right? And we're going to go negative square root of 8 just because it's easier to type in, and then square root of 8 for the upper limit, okay, and then pi, and then parenthesis, and then 2 minus, and then alpha window for the fraction bar, and then x squared over 4, and then close the parenthesis for that, and I need to square that, right? And then the thicknesses are dx, okay? And we get 37.913, okay? So 37.913. Okay, guys, let's, and so this region, I'm gonna go and I'm gonna show you what this region will look like, okay? Because I just think it's cool to see, okay? Okay, and then, hold on. Okay, okay, so this is what it looks like. It kind of looks like a lemon. Okay, so that region that we talked about, that we just found the volume of, this is actually the solid of it. Okay, I'm going to go back to the orientation, and I'm going to animate it. And so this is what it looks like when you start rotating it. I'll come back to the back side so you can see it more. Okay, so that's what it looks like. And then we'll do one more of these for the last one. Okay. Okay, for the last problem, we want to set up an evaluated integral that gives the volume of a solid formed by the region bounded by the y-axis, x equals negative y squared plus 4y, this curve right here, for 1 is less than or equal to y, less than or equal to 4, by revolving the region about the y-axis. So we're rotating around this y-axis, right? And what I just said earlier is that we got to go perpendicular to that, so that'd be going horizontal, right? And to the curve, right? So from the line we're rotating around, or the axis we're rotating around, to the curve. And that's my radius, right? Now that's a horizontal measurement, right? So that's going to have to be, we're going to have to get the change in x, right? So our functions need to be in terms of x. So these equations need to be x equals, right? So this r that we're talking about here is this, the one on the right, right, which is this negative y squared plus the 4y, okay? That, and then minus this line, right? And that line is x equals 0, so minus 0, okay? So our radius is simply negative y squared plus 4y. So the area is equal to pi r squared. And what's our r? It's negative y squared plus 4y. So our area is equal to pi times negative y squared plus 4y squared. Okay, and that's our area. Okay, now we want to integrate this, right? We want to create these starting right here at 1, and we're going to stop making them at 4. So the volume is going to equal an integral, and it's going to be from 1 to 4 of pi times negative y squared plus 4y squared, that quantity squared, because that's your radius. And then it's going to be not dx, but dy, okay? And then this would be equal to, we're going to do this one by hand again, okay? So pi times the integral from 1 to 4 of negative y squared plus 4y dy, okay? And then we're going to, and then square, whoops, okay? And then we want to square this. So this would equal pi times negative y, and this would be not negative. Whoa, whoa, whoa. It's getting late. I'm starting to get tired. Okay, this would be negative y squared and times negative y squared, which should be positive y to the fourth. And I need to integrate. Hold on. Let me erase this. We're integrating from 1 to 4. And if we square this out, it would be y to the fourth. Okay. And then when we multiply and double, right, because we have to go negative y squared times 4y. All right. And then this negative y squared times this 4y, right? If we were to write it out, and it would give you negative 8y cubed. So minus 8y cubed. And then 4y times 4y would be 16y squared, and then dy. Okay, so that'd be pi times, and this would be y to the fifth over 5, and then minus 8y to the fourth over 4, and then plus 16y cubed over 3. And then we want to evaluate this from 1 to 4, right? So this is equivalent to pi times 4 to the fifth over 5 minus, and 8 over 4 is 2, so 2 times 4 to the fourth plus 16 times 4 cubed over 3, and then minus pi times 1 to the fifth over 5 minus 2 times 1 to the fifth, and then plus 16 times 1 to the third over 3. Okay, and then this would come out to be pi times, and 4 to the fifth would be 1024 over 5 minus, and 4 to the fourth is 256, so 512, and then plus 1024 over 3, and then minus pi times, and this would just be 1/5 minus 2 plus 16 thirds, right? Okay, so cleaning this up, we would get pi times, and I would put this in a calculator, okay? 512 over 15 minus pi times, and then 1/5 minus 2 plus 16 thirds would give you 53/15. And then you'd be able to subtract these, right? Because this is really 512 pi over 15 minus 53 pi over 15. And that would give you 459 pi over 15. And I forgot to slide it up. Okay. And so that's the volume of this. Okay. So let's just make sure we're right, because you could put it into your calculator, right? You could put the integral. Okay. So the integral from 1 to 4. Let me slide it up a little bit so you can see it. Okay, so from 1 to 4, and then pi, and then negative x squared plus 4x. We can't type y, we're going to type x, and then close the parenthesis, and then we need to square it, and then dx. Okay, and then put the fraction 459 pi over 15, and we get the same thing. Okay, so we know we're right. Okay, all right, you guys, that's it. Let me get the assignment sheet and we can do that. Okay, so what I want you to do is I want you to do page 411, 7 through 14, all. And I'm going to go ahead and I'm going to give you guys, I'm going to give you a picture of the page too, okay? So that you guys can do this, okay? If you don't, if you don't have your textbook anymore, okay? That's it, guys. Have a good day.